Hello everyone, my name is Nickolaos Contaxakis. I'm a cloud solutions architect at Onyx. This week's Google Next videos focus primarily on security technologies. Today I'm here to talk to you a little bit more about the newly minted confidential VM instances. So, as Google is proud to say, they've designed their GCP platform from the ground up to provide its customers and users with one of the most secure platforms available. They've even gone so far as to design and build their own hardware, software, firmware, and chips to be able to control the entire stack and guarantee the highest level of security. As most of you are certainly aware of, data in transit and at rest by default is encrypted. Moreover, they provide users with full control of those keys should they choose to do so, including but not limited to leveraging third-party KMSs. So, let's talk a little bit more specifically about confidential VMs. So confidential VMs are built on top of Google shielded VM technology to provide the next level of protection and encryption to those instances. The concept at the end of the day is really simple. We already know that data is encrypted at rest. We already know it's encrypted in transit. But what happens when it runs in memory? Well, now Google's confidential VMs answers that question. It allows that memory, what's running in active memory, to be encrypted. So this announcement is very significant for a number of industries where they have significant concerns about PII or other kind of security issues. This allows those organizations to start considering a cloud-first strategy because it now closes that final barrier, that final loop for a specific number of workloads that they weren't able to run in the cloud previously. Well, one can imagine that encrypting the information as it enters memory and exits the memory would come at a price. And Google has started to leverage, or is leveraging, I should say, AMD's EPYC second-generation processors to help minimize that performance penalty. Google's leveraging their secure encrypted virtualization capabilities to keep VMs running encrypted in memory without experiencing the typical kind of penalty we would expect. This processor provides each VM with its own key, which is generated by the processor during the VM's creation. Now, this is important because this means the key resides only within the processor and is not available to either Google, the host, or any of the other VMs running on that very same host. So let's answer the million-dollar question. What kind of performance penalty can we expect? And as with everything in IT, the answer is, well, it depends. However, AMD and Google have done some testing, and they've determined that the typical performance penalty you can expect would be anywhere between 1% and 6%. For example, running Nginx with a load balancer, one can expect anywhere between 1% and 4% penalty. As is the case with everything with Google, Google's working closely with AMD's engineers to try and optimize those numbers and reduce that penalty even further. If you have any questions about shielded VMs, confidential VMs, or anything else related to Google solutions, please feel free to reach out to us at Onyx. We'd be happy to set up a call with you. We hope you enjoy the rest of Google's Next 2020. Have a great day.